and welcome back to Advent of Code, and we're doing day 12 and part 2 now. So part 1 we basically did a star search algorithm to, what we're trying to do, we're trying to find a path through a hill. We're trying to get to the top of a hill basically, and this is our map. A is like the lowest point and Z is the highest point, and capital S is the same as an A, and it's also your starting point for part 1, and E is the same as a Z, and it's the same, your goal point, your destination in part 1, and you just want to find the shortest path. So this one is like a spiral around and you get to E. Part 2, what is this? Right, so you want to basically make a hiking trail and make it good, and where you start in part 1 is not very great. So now we're just trying to find shortest path from any A's, so like this, I guess, S counts as an A, so this A, this A, this A, this A, that A, all the A's, and you're only trying to get to E? You're only trying to get to E, so not just any Z, it has to be that E. And you want to reach this in 20, well, this one reaches in 29, which is shorter than where the S started from. And so, we kind of just need to, so this was our, like a star, I guess. So what I might do is actually make it a function, a star, and it can just return I64, I guess, and we'll paste in whatever the input there was, and maybe it can be I64 question mark, and here we just return gs current I, and we can probably do bang here, and here we can just print line part 1, and that is going to be a star, and we probably have to pass in our grid start and goal, and that. So our grid is a grid, start is a point, and our goal is also a point. That is tab. Right, so the rest of this code kind of just works for any start and end goal. So what we can do is, probably do that and do that. So that's where we return from that, and we return none at that point. Theoretically, we could actually not have the exclamation mark, which unwraps the optional, because we return an optional, I guess. But what we do need is that to have a bang. We are assuming that we're going to get a solution. And what we should do is test that that still works, and it doesn't. So we should work out why it doesn't. Right, so we need throws on that because we create a set throws. And that now builds. It does not build. Right. Constructor. Gosh, that is a slightly different error than I've seen. Maybe if we do something like that. don't want to actually unwrap it there, but we will unwrap it there. So this potentially could be none, but it should not be, because basically to get to this point, we've like set what it is, because we will add in the G's for any neighbour that we find before we add it to the open set, and then when we pull it out of the open set, it should exist because it's past this point, and we also set the start one, so that should always be a value. But anyway, it is passing. So what we need to do now is, when we're passing our input, we also want a list of the A's. So part 2 start. Or like lowest points. Yeah, I'll just do the lowest points, and in this parse, we will also return an array of points, and we can probably have lowest points, and this can be an array of point, and it can be initialized to nothing. And now we can lowest points dot push, and we can push start, because start is always going to be. And in this one, we want to test whether if B equals B A, then lowest points dot push B. Not B. We want to make a new point, and X can be it's basically this, but with an extra thing, and close that off. And when we return, we also return lowest points. So part 2 is basically for we can do it P in lowest points, and we also probably want a mute min equals, we could probably, I might do this, do that. And right, so part 1 will just be whatever the goal was to start with, and then in lowest points we want to go let's we can call it D, I guess, and it's going to be A star with grid and P, and we can call it start and goal, like that, and we can bang it because it should always have it. In theory, we can like potentially one of those points might be blocked for some reason. It shouldn't happen in this because there's no you could actually have a blockage because you can only climb one up. So potentially you could have a say we have like S, A, B, C, E, something like that. We can go from S to E, and we're just assuming it's one directional here because I can't be bothered. And say we had S, A, C, E, and we don't have that B in between. There's actually no way to get from that point to that point. So in that instance, A star would return none. So I think I won't unwrap it, and I will do .d has value. So if D has value and D is less than min, then we will set the min to D bang, like so. and then at the end of that loop, we can go part 2 equals min, like that, and cool. And I might go min outputs day, what are we, 12.example, and 29, I reckon that would be. And if we run the test, we should not compile. Cool, that's fine. We just need a bang on the D. It's kind of interesting. So there's, in jakt, there's like guard type things. Maybe we can have a look at them. Vim samples guard, and maybe just look at the basic. So maybe it wasn't guard that I was thinking of. So there's a like a construct in the language that basically it will infer that like potentially if we did something, like basically because D has value, the compiler would infer that inside this block D has a value, so we don't need to unwrap it. But I think it doesn't show up in this case. It potentially does. And right, that is in this. So I think it did actually do what I wanted. Lowest point start, expected point, but we got point question mark. So we got an optional point for that start. That is because start is actually an optional, but even though we like assign to it. So like here's an example where the compiler probably could infer that start does indeed have a value because we assigned to it in the block. So after the block, it should know, but like the compiler is still work in progress, and it's got a lot of cool features, but it's still a work in progress. So that's kind of what you get. Right. So this is interesting. When I started that kind of spiel on that this block knew that D had a value, I've noticed that jakt itself realised it did, but then in the C++ it didn't. So we do actually need that, and then it should get past the C++ compilation. And now we should get a pass on the example, that is good, and the actual input is taking a long time. Now, there are ways I can speed it up. Well, we got an answer, so I'm going to submit that. 402. 402 is the least, and it was right. So that took like 7 seconds. I am recording a video at the same time, and I'm running this inside of the VM. It's still quite slow. The 11.output, 402, day 12.output. And that is 402, and I guess increment that just the once. And so now if we run it again, it should pass twice, but it will take 7 seconds. So what I could do to speed this up is this get lowest. We're like operating on a set and we're basically looping over every element in a second. That one took like nearly 9 seconds, but we passed. If we change this open from a set to a new construct of like a, you can call it a heap. In fact, it even mentions it in this A star. If it's a min heap or a priority queue, both of which I can implement, that would reduce it from like n time to I like clicked on something or like did a scroll and it like went away. it would go from a order in time, and like what we could do is print line open size equals this, and open dot, I believe it is size for a set, and if we run this we should get like the sizes of that open set that it's looping over, and right, everything is one there. Well, it'll be like kind of an interesting one. So we probably have yeah. So there were a couple of 3-digit ones. So I think I will, if open dot size is greater than 100. Maybe I'll start with 1,000 and only print the real massive ones. But it could be that we have to just do as greater than 100. So in the example, there's nothing over 100, so our search space is quite small. In the actual, it also didn't go over 1,000. So maybe I'll do 500 and see if there's any on that level. So our size is not massive, but we're doing it quite often. Potentially there's nothing more than 500 in there. Alright, we'll go with just the 100, because I did see some 3-digit numbers going in there. Right. And so now we run and we wait and we run and we wait. And so here we have some outputs. So it looks like it just gets over 100. Some in the 20s, some in the 30s. I think I saw 130. So we have this, but you can see it's running it many times. Like we actually run out of scroll buffer. So this function is being run all the time, and every time we are looping through, sometimes up to 130 ish values, and then we're like testing whether it's in like this dictionary. The dictionary is a hash, so that should be order 1. But this function at the moment is order n. We have to loop over each of those 100 things every time. If we did a min heap or a priority queue or something like that instead of a set, then the operation would be very quick to actually get the... It's interesting, they say it will be order log n time to find the lower score, but I believe it's actually order 1 time to get the lower score, but to remove it would be order log n, because you need to find the next minimum to put at the top. That it can be an order 1 operation, but really that we wouldn't be at the goal unless we wouldn't get that order 1 logic unless we were at the goal for that point. Otherwise we would just always have to remove it. So what, we could optimize it, but I think I will come back to it and maybe just have a fix me implement a min heap or priority queue to reduce this to order log n. Currently it is order n being around 130 for input. This is also run many times in the start function. So I might come back to it later and optimize things. But if we run it again, this should take around 8 seconds or whatever to do it, and I am happy that I have solved day 12. So if we go back to this, that's not lit up yet, but if we bust some cashews, maybe with those letters, bust, then we get some colour up there. And that all passes, so if we look at our status, that looks all good. We will commit things up, day 12, part 2. And we'll quit that and we'll push that up. And I think I can just push. Oh, no, I probably do need to pull. Yeah, I do. Because I would have updated the README when I pushed part 1 because I got a star. And if I do this, it will also kind of do it. And what I mean with that is I can probably go to it, github.com/import/advent of code 2022. And so if we look at this, it's like not loading everything. Are we still like refreshing things? I'd think it would look better than this, but that was when I was running the Ladybird, the browser that can run on Linux and stuff. Because yeah, this isn't showing like a bunch of stuff, and like these will be icons and stuff, but I think the like the last commit will be by the bot, because yeah, so update badges, that is the last. So I pushed that and this kind of happened straight after, and what this commit would have done, which we can also fetch, pull, we can also pull that. What that did was basically say we went from 23 stars to 24 stars, and we completed day 12, because we hadn't completed it, we'd only half completed it. And we can see that same commit there, that goes from 23 to 24 and 11 to 12. So, that's enough for this video, so I will see you next time for the next day 13. Ooh, spooky. Not really that spooky. It's gonna be like a Tuesday my time. Yeah, we're Tuesday at the moment, so it'll be Tuesday